Hello, viewers. Welcome once again to the continuation. This happened to be episode 30, but I think the seventh episode on the motion along inclined plane, still under mechanic dynamics. So a body slide down from rest on a smooth inclined plane, which is 50 meters long and 5 meters high. We have to calculate its speed on reaching the bottom of what? The plane. If we can just take a small sketch of this, the angle of inclination, the body is moving slide down at a distance of 50 meters. Then the height obtained is going to be 5 what? Meters. Information provided as a slide down from rest, meaning initial velocity is 0 meter per second. Then the height is given, the distance travel by the object, the body, the distance travel is going to be this as it is moving down. The distance up is 5. So I'll be making use of this as our distance travels to be 50 meters. What again do we have? I think time is not mentioned, but we can think of the acceleration of the body, which we know is what? G sine what? Theta. What again do we have from this question? I think these are the information provided. We are looking for final velocity, which is unknown. So if that is the case, knowing very well that final velocity, initial velocity, the use of distance without time, we will go in for the third equation of what? Motion, with each alteration based on inclined plane. In that formula, the angle of inclination needs to be determined. So I'm only going to use trigonometry to find that angle by saying that from the diagram, using trigonometry, I will have the sine of the angle theta equals to the opposite side, which is 5, divided by the hypotenuse, which is going to be 50, giving you 0.1. And here, I may not even continue to find the angle of inclination because sine theta is being featured in here. So I only say acceleration is going to be, so that means your acceleration become the gravity from here, which is 10 times sine theta, which is going to be 0.1, giving us 1.0 meter per second square. So acceleration is found. So I only say from v square equals to u square plus 2as, where the a, remember, is supposed to be v square equals to u plus 2g sine theta s. But because we already found the acceleration, that is why the a is here, just like the initial equation of motion. So what are we looking for? Final velocity. So that's v square, initial velocity, 2 times 1 times this, which is going to be 50. I'm using 50 because of the distance travel. In this case, not distance up. The distance travel is going to be 50. Then 5 is the distance drop. Okay, that is the height at which it is above the ground. So this means that v square equals to, this is 100, and v become the root of 100, giving us 10 meter per second. So the velocity or the speed at which the body will get to the bottom is going to be 10 meter per second. But I can also digress a bit from all the formulas we have indicated earlier on and see that alternatively, we can say that if the body is at the top, motionless, it means that the potential energy of the body can be determined motionless. It is there as a motionless. Now, when it begins to move, then the potential energy will be converted to kinetic energy, meaning potential at the beginning will be equal to the kinetic energy at the end. So we can only say that potential energy equals to the kinetic energy. How do you find potential? That is mgh equals to kinetic half of mv what square, which is what you're looking for. The mass of the body is unknown, and in this case it can be cancelled out. So gravity and the height. Here the height above, this is potential energy, the height above the ground is going to be 5. So I will have 10 times 5 equals to half times v squared. I believe we can multiply both sides by 10. This is 50. So we have 100 equals to v squared. That makes v equals to the root of what? 110 meter per what? Seconds could be. So this could also be one alternative way of finding the velocities if that is what you're looking for. The height can be determined from here. The mass will automatically cancel. So we can either find the velocity or the height using this very approach. Thanks for watching. Like, share, comment, subscribe, and come back for more.